SPIDER radar system. It is a search radar. It was actually bought from Reutech Radar Systems by us, which is the CSIR, to actually do research into search radar capability and to actually help us with our tracking radar work that we do.
Inundu is going to be a platform that's going to take us into a new environment. It's an airborne EW test platform that allows us to actually evaluate technology on a fast jet. It will allow us to take electronics from the lab into the air in a very cost-effective way.
Its main objective is for training and simulations. So we simulate electronic warfare electronics, or for training in electronics warfare environment. And for example, we can do anti-jamming simulations or radar jamming simulations.
The strategic intent of Inundu is to develop an airborne test and evaluation platform to test EW systems and also to support the industrial development in the radar and EW sector, and also to support the SNDF to train the EW operators and the Department of Defense to obtain their strategic independence.
MECOT is our primary tracking radar during this experiment. We're using it to see the jamming signals being generated by the pod flight. MECOT will act as a primary radar that the pod will try to generate its jamming techniques against. We'll use that to look at the jamming techniques that the pod is generating and see what the effect of those jamming techniques on the radar is.
The big difference between a search radar and a tracking radar is that a search radar has a full 360-degree view around itself. And the benefit that we get with SPIDER is that we're able to get something that is in azimuth, which is your full 360 degrees around you, as well as in range, which is how far away is it from you. That helps us because then with the tracking radar, we can use that as something to designate or point us towards that. A tracking radar really has a very narrow field of view, so think of it like a telescope or something. It's pinpointed to somewhere. So the search radar actually helps us determine where we want to look, and a tracking radar will go and pinpoint what is exactly there.
The Enigma 4 has electronic support and electronic attack capabilities. First of all, electronic support to try and determine which emitters is out there, to try and measure their frequency, and then try and also see what radars is out there and classify them. The electronic attack portion of the system can be used then to generate false targets or spot noise to the radar that has been classified. The electronic support side of the system is also used to try and determine the frequencies and the pulse descriptor words of the RTS system, also in the Inundu pod.
This is the situation awareness display. It's allowing us to actually get both the SPIDER tracks as well as the MECOT tracks into one area view that we can see where we are relative to a variety of other things around us. So the very nice part about this is that you can see these purple lines and dots are exactly like I mentioned earlier, a search radar providing us with possible detections. The dashed grey line is MECOT, so it's a tracking radar, so it's only looking in one particular direction at any point. So you get that feeling of a full 360-degree view with Spider, and then you get that sort of pencil beam view with MechWort.
We brought in the standalone tracker platform along with visual and thermal optical sensors. Basically, the standalone tracker system is just a platform where we can mount different types of sensors for testing. The point of this deployment is to demonstrate the interoperability between the visual standalone tracker system and along with the radar system. We can receive designations from the radar systems, and then we can do visual confirmation of targets. And then we can also track terrestrial targets for them and then relay those designations to them.
So what's even greater about this is that this allows us then to integrate whatever we're getting with our radar sensors, because that's what the view is here, and allows us to integrate with optronic sensors and even into command and control infrastructure, which then gives you a very nice consolidated view. And I think that's the real benefit, because we always just see sensors on their own, but we never see this fully consolidated view, and that is actually something we want to aim for.